This video will cover the third page of notes on the topic of graphing polynomials. Let's do examples that encompass all the information we have learned so far. For example 3, we have the p of x in factored form. For step 1, we need to find the y-intercept. We will let x equal to 0 and solve for y, or the p of 0 value. I will plug in 0 in the factored form of p of x and see that p of 0 is equal to negative 4. The y-intercept is the point 0, negative 4. For step 2, we need to find the zeros of p of x. Since p of x is already in factored form, we can solve for the zeros by setting each parenthesis equal to 0. We will then find that the zeros of 1/3 and negative 2. Notice that we had two parentheses of x plus 2 because the square power tells us that. This tells me that the 0 of negative 2 has a multiplicity of 2. Since we did not do synthetic division, we do not have extra points, so we will skip step 3. For step 4, we need to look at the end behaviors for p of x. Since p of x is in factored form, we need to find the leading or dominating term. We will simplify the factors into 3x and x squared. We got rid of the constants of the linear factors. When we multiply 3x and x squared, this will give us our leading term of 3x cubed. So we know that p of x is a cubic function with a positive leading coefficient. So the end behaviors will be similar to that of the parent cubic function. The left end of the graph will go down to negative infinity, while the right end of the graph will go up to positive infinity. For step 5, we do need to remember that we have a 0 that has a multiplicity of 2. This means that the graph will only touch and bounce back at the x-intercept of negative 2, 0. Finally, we need to graph our points and end behaviors as seen here. Now, we can connect the points to our end behavior arrows. Starting on the left, we will go from negative infinity to the x-intercept of negative 2, 0. And since it has a multiplicity of 2, we will touch the x-axis and bounce back down. We're going to hit the y-intercept and go up to the x-intercept of 1/3, 0. And since this one has a multiplicity of 1, we will go straight through it and connect to the end behavior arrow that is rising to positive infinity. Finally, let's do example number 4. We are asked to graph p of x that is not in factored form. Step 1 is to find the y-intercept. Step 2 is to find zeros. First, we need to factor p of x completely in order to find the zeros. We will factor out the greatest common factor of negative x. Now we have a cubic function that needs to be factored. We will need to use synthetic division and some guesses. Looking at the factors of 18, I will guess 2 is a 0. I will use synthetic division to verify that it is a 0. Now we have p of x factored as negative x times x minus 2 times the quadratic expression of x squared plus 6x plus 9 that you should be able to factor on your own. Here is p of x factored completely, so we can see that it has the zeros of 0, 2, and negative 3. For step 3, we did do synthetic division, but we did not find any extra points for our graph, so we will skip this part. For step 4, end behaviors. From our leading term, we have the quartic function with the leading coefficient of negative 1. The parity, or the exponent, is even, so both ends of the graph will go in the same direction. Because the leading coefficient is negative 1, the ends of the graph will go down towards negative infinity. Step 5 is multiplicity. We found that the 0 of -3 has a multiplicity of 2. This means that the graph will only touch and bounce at the x-intercept of -3, 0. So we will need to keep this in mind when we graph our polynomial. Step 6. We are ready to sketch our graph, plot our points and end behaviors. To connect our points and create our curve, starting at the left, we will go from negative infinity to the x-intercept of -3, 0, which we will touch and bounce back down to go to some value and then turn upward to our next x-intercept of 0, 0, and continue through this point since it has a multiplicity of 1. And then I will need to come back down to go through 2, 0 and continue to the negative infinity. This concludes this video.